Alrighty. So looking at solving systems of equations using both substitution and elimination, we do not really solve systems in here by graphing just because it's not a very accurate method, really. Our algebraic method, substitution and elimination, is going to be the best approach, okay? So before we really get into those two methods, let's talk about what a system of equations is first. And all that means when I say a system of equations is it means that we have a group of two or more linear equations. A group of two or more linear equations. In Algebra 1, you guys only worked with systems that had two equations. So what we get to do is have a little fun and throw in a third equation and a third variable. It's gonna be fun. Okay, so what I really want you guys to understand when we are working with systems is what the solution to a system means. A solution to a system of equations is going to be an ordered pair. I should also probably say or an ordered triple, which again we'll get to later on. This is going to be an ordered pair or an ordered triple that satisfies all of the equations in the system. What that means is if you have an ordered pair like 2, 3, so your x value is 2, your y value is 3, if you plug those x and y values in both the equation, you're going to come up with true statements. This is what it means to satisfy an equation. Graphically, what it means to be a solution to a system is it is where your two lines cross, okay? So it is a point that is in both lines, which is why it satisfies the equations algebraically. Okay. All right, so we are going to start with a couple of examples, kind of reviewing substitution, and then we'll jump over to elimination. So when we are solving using substitution, we want one variable by itself, or one variable isolated, to get us started. Now, you have some choices in which variable you want to isolate. You can choose a variable in either equation, and you can choose either x or y. Now, with that being said, there's usually a better choice. Okay, so what I mean by that, let's look at that first equation, for example. We have 7x plus y equals 6. Which variable in that first equation would be a little bit less work to solve for? Isaac? Y, okay. It would take us 2 steps to get x by itself, but to get this y by itself, all we have to do is subtract 7x. So even though it is totally up to you what you want to choose, there's usually kind of a better option. So we have y equals negative 7x plus 6. We have that variable by itself. We are going to circle the expression that variable is equal to, and we are going to take that and we are going to plug it in this case, to the y in the other equation. So we are going to rewrite the second equation. So we're going to start with that 5x. We bring down that negative sign, but instead of writing that y, we are substituting that expression, negative 7x plus 6. And then we're just going to bring down equals negative 3. what we've done is now we've created an equation that just has one variable that we can solve for. So we are going to start off by distributing the negative. And then again, it's just solving a linear equation from here. We can combine our like terms, so the 5x and the 7x gives me 12x. We can add the 6. And then when we divide by 12, we get 3 over 12, which is 1/4. Do you guys remember what we do to find y value? Yeah, we take that x value that we just found, we substitute it in. You can take that x value, you can substitute it in for x in either of the two original equations. We can also use that y equals negative 7x plus 6, which is actually the one I'm going to choose. So taking that 1/4, substituting that in, and we just need to simplify to get our y value. So this gives me negative 7 over 4 plus 6. And then quick little trick that will help you moving forward. You could make a common denominator and add these by hand if you want, but let me kind of show you how to do it on graphing calculator. To type in that negative 7 over 4, put the fraction in parentheses, and you're just using your division sign to get that fraction bar. And then I can type plus 6, hit enter. Now it gives it back to me as a decimal. If you are working on a TI, your favorite new button is going to be this. Hit that button that says math over on the left, and then option number 1 is to a fraction. Hit that and hit enter again, and it will give you, I know, right? Casio people, I'll look at you later. Best day of your life in math, math 1. Don't forget it, okay? So right away, we have that beautiful improper fraction of 17 over 4 for our y value. Then all we need to do is take our x and y value, write them as an ordered pair. Cool? All right, I'm going to give you guys a couple of minutes to do number 2 with your group. Let me ask you this question before you get started. What variable would probably be the best to solve for here? Mitchell, what do you think? Which y? The first one, okay? So a couple minutes with your group. I would agree with Mitchell that that would probably be the easiest variable to solve for. So do that, substitute it in and solve. Let me know if you have questions. And you should not be getting fractions on this. You should not be getting a fraction, so if you are, you will get it. Okay, not looking too bad here. So starting off to solve for that y, we end up with y equals negative 3x plus 8. So we are taking this expression, substituting it in for y. So a couple of you saw some common mistakes, so just kind of watch out for a few things. So when we bring this 18x down, make sure you bring down that coefficient of 2 as well. So plug in that negative 3x plus 8, and then we can solve from there. So distribute the 2, and then combine like terms and solve. So I get 12x equals negative 12. So our x value should be negative 1, and then we can take that negative 1, again, substitute it back in any of the 3 equations that we have. And we should be getting that y equals 11. And then again, I do want you to understand, because this is where our lines cross, this is a point. We want to write that as a coordinate, okay? Questions? All right, so let's look at a word problem that uses substitution to solve. It says that the sum of 2 numbers is 27. So sum means addition. So let's say that our 2 numbers are x and y. You could pick any variables you wanted, really. So how can I turn this sentence into an equation? The sum of 2 numbers is 27. X plus y equals 27 gives us our first equation. And then the second sentence tells us that the larger number is 3 more than the smaller. We don't know at this point which one's the larger one and which one's the smaller one, so you just kind of pick x or y. It doesn't really matter. But we want to put that now into an equation. The larger number is 3 more than the smaller. What do you think? Allison, what do you think? Okay, so pick one of your variables to be the larger number. Okay, so y. And then what's is in math? Okay, so y equals, and then 3 more than the other. How do we say 3 more? You're thinking too hard. How do we say 3 more? Yeah, exactly. So 3 more than the other number. And then we already have a system where we have a variable by itself, so we can go ahead, substitute that 3 plus x into y and solve.
So once we substitute, I'll have x plus 3 plus x equals 27. And then we can solve from there. So 2x plus 3 equals 27.
When we combine those like terms,
subtract your 3 and divide.
So one of our numbers is 12. If our two numbers add up to 27 and one of them is 12, what does the other one have to be? 15. Very good. So no work really that we even need to do to get that other number. If you want to plug it back in, you certainly can, but what questions do we have so far? Okay, so let's kind of take a couple examples to review. Now, elimination. This is usually the one you guys prefer. Elimination is really good to use when you are given both of your equations written in standard form, okay? Where you have your variables lined up, your equal sign lined up, and then your constants lined up. Now, our goal is to be able to add these two equations straight down and have one of our variables drop out or eliminate, okay? Now, if I were to add these two equations as they are, does anything drop out? No. What do we need to do to make that happen? Colin? Make the what? This? Yeah. Well, if I make that negative, when I add down, I still have 1a. My goal is to get one variable to completely add to 0, basically. So that's not really going to help us. Tori? Yeah, if we multiply the top equation all the way through by 2, let's see what happens. So we are going to distribute that all the way through. That gives me 4a plus 2b equals 10. Now when I add straight down, I have 7a, but then a negative 2b plus positive 2b is 0. So those drop out, which is what we want to happen. In doing that, we're down to an equation with just one variable. We can divide and solve for a. And then again, just like we did with substitution, to find the value of our other variable, take what we have, substitute it in any of your original equations. I typically just go back to the first one, plug in that 3, and solve for b. So 2 times 3 plus b equals 5. And we can solve from there. So you guys are used to using x and y. If you are given variables other than x and y, go in alphabetical order when you write your ordered pair, okay? Alphabetical order. So in this case, A is first, then B. What questions do you have? Okay, if you look at the next example, kind of analyze that for a minute. There's no equation that I can multiply by to get a variable to drop out. So what we need to do in this case is actually multiply both of the equations by something to force that to happen. The easiest way to figure out what to multiply by, look at your two coefficients. So you have a 7 and a 3 here. Switch those.
So multiply the top equation by 3, the bottom by 7, and then make one of them negative. So look at those two leading coefficients, switch them, and make one negative. So if you kind of think ahead about when you would distribute, what do we end up with? A negative 21x and a positive 21x, right? Okay, I want you guys to go ahead and finish this. You have to distribute those numbers to everything in those equations. Watch your signs as well. Okay, so go ahead. We did the first one for you. Distribute the 7 to the second equation and go from there. And you should not be getting fractions. Should not be getting fractions. Okay, looks like most of us are on the right track here. So if I distribute that 7 to the second equation, I should get positive 21x plus 35y equals 98. And then when I add, my x terms drop out, and I end up with 47y equals 47. So then y equals 1. And then we can take that value of y, again, go back to either equation. You can even plug it into one of the new equations that you have after you distribute. It does not matter. You should end up in any case with your x value as 3. Questions? You ready to now take it up a notch? So everything we've done so far, we've seen in Algebra 1. Now we're going to take it to our next level. And actually, I wish these next two examples were in opposite order. We're actually going to look at number 4 first. This one's a little bit easier than number 3. So notice that you have 3 equations, and we are going to end up looking for the value of 3 different variables, x, y, and z. Now, right away, this example gives you the value of x. So you are told that x is 4. So our answer is going to be, I mentioned earlier, what we call an ordered triple, where you have the values of x, y, and z. They're still in parentheses, but you're going to separate those values by 2 commas. So right away, when we go to write our answer, we already know that the x value is 4. You can go ahead and plug that in. Oh my gosh, we are so going to run out of time. Crap-ola. Okay, we'll do what we can. If we need to finish this next time, that's no big deal. All right, so we are going to start off using the fact that we know x is 4, and we are going to substitute that value of x into the second equation. So if we do that, again, plugging 4 in for x plus y equals -6, then we can solve for y. So we're just going to subtract 4 and get that y is -10. So you can go ahead and put that in your ordered triple. And then what do you think we're going to do to find z? Plug both x and y into that third equation, and then we'll only have z to solve for. So this will be 4 times 4 minus 3 times -10 plus 2z equals 26. Okay. And then just be really careful when you are simplifying and solving. So we get 46 plus 2z equals 26. We can subtract and solve. So z is actually also -10.